Price, that's the number one technical indicator.
You do best by investing for the longer term.
If you can't explain what the business is doing, then that is a huge red flag.
Some technological change is going to put you out of business.
It really is a genuinely extraordinary situation.
Hello everyone, I'm Ed Gotham. Welcome to another episode of Opto Sessions, where we interview the top traders, investors and public companies from around the world, uncovering their secrets to success. This week we've got Bob Brown on the show, CFO at AEye. That's spelt AEye. AEye is a leader in AI-driven LiDAR systems for autonomous vehicles, advanced driver assistance, and robotic vision. Bob has over 30 years of experience, completing over 20 billion in financing and M&A transactions, and has a rich history of working in C-level positions at various other LiDAR companies. In this interview, we discuss how LiDAR is the future for autonomous driving and robotics, how the technology works, including details of how it accurately tracks a speeding bullet, and what unique selling points AI has over its rivals. Enjoy. Hey Bob, great to have you on the show. How are you doing today?
I'm doing great. Thanks, Ed. How are you?
I'm great. Yeah. Where are you calling from?
I'm in Silicon Valley in California.
Oh, wow. How's everything out there at the moment?
Not bad. It's been a little cooler than usual, and we got a little bit of smoke here from all the fires, but otherwise we're doing well.
Oh, you got fires there as well? God,
yeah,
all over the world.
Pretty far north of where we are, fortunately, at the moment, but the smoke is drifting south. So we're thinking about all the people that are getting exposed to that issue at the moment. So unfortunately, become sort of the new reality in California and a lot of other places.
Yep. Yeah. Well, it's great to have you on the show, like I said, and an amazing opportunity again for us to talk to someone who's at a public company. So obviously you're the CFO at AEye. Could we kick off by just talking about what is AEye and introduce it to the people on the show?
Yeah, absolutely. So we're a LiDAR company. So we call ourselves a premier provider of high-performance adaptive LiDAR systems, and I'll explain more about what that means for vehicle autonomy, advanced driver assistance systems, or ADAS as it's known, and robotic vision applications. So there are a number of different LiDAR companies out there. As you know, we really think of ourselves as a next-generation LiDAR player in the sense that we have delivered, as the name implies, we're AI enabled. So we put artificial intelligence into our system, and it's also a software definable platform. So we really think we're at the cutting edge here in terms of LiDAR technology. And it's got all sorts of different applications, as I talked about, around vehicle autonomy, as well as all sorts of different robotic vision applications.
And the primary focus for you guys at the moment is autonomous driving, sort of an element of helping in that area.
Yeah, that's definitely one of the big focus areas for us at AEye. So, there's a tremendous amount of interest in the vehicle autonomy space around LiDAR. And as you probably know, there's been a lot of use of cameras and radars historically. And now a lot of the people that are in sort of thought leadership positions around vehicle autonomy are starting to implement LiDAR. And I can tell you more about that if your listeners want to hear more about how the technology works and what it's all about. But it's basically a third major sensor modality that really complements the other existing sensor technologies that are out there in vehicles today. So it just makes vehicle autonomy much more possible because of the additional capabilities you get from LiDAR.
And so I'm right in saying that it's an aspect of autonomous driving, and it's on the end of determining potential things in awareness of what's happening around the car at any one time. Is that right? And it feeds that information into sort of a self-driving software that it might connect with.
Yes, exactly. And so you can think about it as basically almost being like the eyes of the car. What LiDAR does is shoot out a laser pulse, and what most LiDAR providers do is what's called time of flight. So it shoots out a laser pulse of light, and then based on how long it takes that bounce back to return, so that light will go out, it'll hit an object typically and bounce back. And based on how long it took that bounce back to occur, you can measure exactly how far away an object is. because we know the speed of light, obviously.
Yeah.
So using that and sending out millions of these pulses in very short order, you can create what we call a three-dimensional point cloud. So think of it as a camera image almost, but it's three-dimensional. So millions of points all over the screen that basically tells you the exact distance to different objects and can tell you the outlines of the object. So you can tell, is it a car? Is it a person? Is it 200 meters away? Is it 500 meters away? So that's sort of data. So it's really is this three-dimensional point cloud, we call it, of data that looks in many respects like a photograph, but it's got a lot more data and information in terms of the outlines of the object and exactly how far away it is, which obviously is critical if you're trying to do a self-driving application, for example.
Yeah. And how does it know? Because obviously there's light everywhere. As long as you're in the daytime, how does that know if it's light that is emitted from the LiDAR rather than something else? Is it a special sort of wavelength or something?
Yeah, so we use 1550 nanometer wavelength, which we think is the best wavelength to use. There's a lot of LiDAR companies are using 905 nanometer wavelength, which has its own issues. We like 1550 because it's a longer wavelength, obviously, as you can tell by the number. But it also gives us a much higher photon budget, meaning we can send out more photons because the 1550 nanometer wavelength is a more eye-safe level in terms of wavelength itself. So it doesn't get past the liquid in the front of your eye. So you can put more power through it, and as a result, you can send out a lot more photons. But to your point, it's got to be looking for those particular photons. So our system is actually pretty unique in that respect, where we can shoot one photon in a particular area and wait for it to come back, and we know exactly where it's supposed to be. So we've got a very unique design in terms of how we've done that, and we can talk more about how that's all architected. But this is really, using our heritage. We really came from a defense and aerospace heritage in terms of the technical founders of the company. And as a result, they really developed a very advanced sort of capability here in terms of, sending out the laser pulse that I talked about, and then knowing exactly where that laser pulse is supposed to come back from. So we have a receiver that is looking for that particular laser pulse and it knows exactly where it's supposed to be. So as a result, it knows exactly where to find it, right? And knows the wavelength, as you said, and everything else. So it's able to distinguish between light that's coming from the sun, for example. But the sun is a key issue for LiDAR generally, and also for cameras, right? That's one of the natural environment issues you've constantly got to deal with and engineer around to make sure you're not getting blinded by the sun effectively. But our system is very good at avoiding those problems.
Yeah. And all this stuff is happening incredibly quickly, like you sort of touched on that earlier. I saw something on your website, a video of it was tracking a speeding bullet, basically.
Yeah, we're really excited about that. We think that's the first time that's ever been demonstrated in a commercial LiDAR. That's something you might be able to do in a military grade system, which costs millions of dollars. But where you could do this with an off-the-shelf commercial sensor, it's really, really remarkable. Yeah, so I'd encourage people to go look at that on our website, which is AEye, AEye.ai. And we've got some really interesting videos out there, including that bullet tracking video. But we basically did that just changing the software. So that's one of the key elements of our system is we really have one platform that can do a lot of different things, which we think is pretty unique in the LiDAR industry, because we can do exactly what you're saying, where we could track a bullet, and then we could, in the next frame, we could say, okay, now we're going to go look for cars, right? And have it do something very different. So we really did that bullet tracking demo just through software. So that's our standard off-the-shelf platform. And we just modified the software on the fly. You just configure it differently, and then we can basically track the bullet. So it really shows the versatility of the system.
Yeah. So this creates the map, like you were touching on again, so that the car can essentially see, or the software can essentially see what's happening in its environment. Now, how do you connect that to some self-driving software that can actually take actions off the back of it? This is the purpose of it, right?
Yeah, exactly. So we'll basically collect data and then we process it at the edge. So one of the things that we do differently from some of the other LiDAR companies is we actually do a lot of the processing at the edge, meaning at the sensor level. A lot of other LiDARs just collect huge amount of raw data and then send all that data back to the self-driving stack to evaluate it. What we try to do is intelligently assess the data and only send the relevant data back to the compute stack. So therefore, the computer system is getting more intelligent information, more useful information, and it can respond more quickly. So you don't have all the latency you might have. For example, if you're shooting laser pulses into the sky, well, there's no cars in the sky, right? But most LiDARs will send back all sorts of data about the leaves on the trees and the sky. What you really care about is what's on the road in front of you. Is there a person entering, the edge of the road from the side? Is there a car in the wrong lane? Any information like that is what you really care about. And so we're trying to capture that relevant data, process it at the edge immediately, and then send only the relevant information back to the central compute stack. So that's one of the ways we're different. But we feed that data back, and you're going to be doing the same thing with cameras and radars. So the camera will take a camera image, the radar will get radio wave images and send that back also to the central compute stack. So basically you'll have at least 3 sensor types that are redundant, and therefore the central compute stack can then assess all that data and decide, okay, what do I need to do now? Do I just stay in my lane? Is there an obstacle in my path? And then the path planning software in that central compute stack will tell the vehicle what it should do. Does it need to stop? Does it need to move to the right or the left? And so forth.
We hope you're enjoying the episode. For interviews like this every Thursday, subscribe wherever you get your podcasts. And while you're there, make sure you give us a star rating and leave guest suggestions along with any other feedback in the review section. Now, back to the show.
And so this central sort of stack, as an example of that, TooSimple, a company that you've sort of worked with closely, I think you've got some sort of new partnership with them at the moment.
Correct. Yeah, TooSimple is one of the companies we're really excited about working with. So they're particularly focused on the commercial trucking market. And so we've been working with them to do some joint development around our sensors. But yeah, they're an example of a company that will take the information from the sensors like our LiDAR sensor and then try to make decisions around how to measure that or move the path of the vehicle. Does it need to stop? So it's really all that decision making that you need to make using the LiDAR sensor data and the camera image data and the radar data. So TooSimple is a great example of that. And they're one of the leaders in autonomous vehicle area for trucking particularly. So so that's a great partner for us. We're thrilled to be working with them. And they've got some big name customers that they're working with. And that's a key market, right? Because there's going to be so much need for autonomy around trucking. There's a shortage of truck drivers, as you may know, around the world. And so it's really becoming a critical use case. And also to reduce driver fatigue, right? If you can even let drivers drive longer, that increases the productivity dramatically and avoid accidents. So it's not just about putting autonomy in and replacing all the drivers. It's also about reducing driver fatigue and increasing productivity. So there's a great commercial application there for LiDAR, and AEye is really pleased to be working with TooSimple and other players in that space to make that a reality.
Mm-hmm. And this should make driving essentially in the future a lot safer, I assume, because eventually the computers will be a lot smarter at decision making than ourselves. And obviously the LiDAR sensors a lot better than our eye at determining things.
Yeah, that's the goal, right? And that was really sort of the founding vision of the company by Louis Dasson, who's our technical founder of the company. And Louis, interestingly, spent a lot of time in the defense area and also aerospace. So he was at NASA for the Jet Propulsion Lab area, and then worked at Northrop Grumman and Lockheed Martin. And so Louis actually developed the sniper pod for our jets. The U.S. Air Force and all the Allied jets use his targeting system. So that targeting system inside those jets is something that Louis helped develop. So he's really got that deep base of expertise around that area. But a key part of what he was trying to do was take that sort of knowledge base and actually put it in autonomous vehicle applications, to make sure that vehicles can see better than humans. And so biomimicry is something that we talk about a lot here at AI, because we're really trying to replicate the capabilities of the human eye and even go beyond that capability. So ultimately, we want to make vehicles even safer than human drivers. And they're not quite there yet, but there's been a lot of progress. But we think AI's LiDAR will help make that vision a reality. And that's really been the mission and vision of the company from its outset.
And how big? I mean, it probably is hard to sort of give us like a number on it, but an approximation. How big do you think this opportunity is in autonomous driving, autonomous trucking?
Yeah, we think it's a huge market. I mean, we've been relatively conservative compared to some of our peers, but if you look at both the ADAS market, which is the driver assistance market, and full autonomy, we think that in total is about a $25 billion market for LiDAR by 2030.
Yeah.
So that's how we've sized it. Some people think it's 150 to $200 billion market in that time frame. So we hope they're right, but and that'll be all upside for us. But we're assuming it's smaller than that, but it's a massive market opportunity any way you slice it. And we think AI is really well positioned to go after that.
Yeah. And could this technology be used for other things like delivery drones and other sort of applications? What sort of other areas are the potential for the future?
Yeah, absolutely. We are going after those areas as well. So what I should probably talk a little bit about our business model, because we've really got this interesting capital light business model. So in the ADAS market specifically, we're actually licensing our technology. So our business model is in that area pretty similar to Mobileye, if you're familiar with Mobileye, which Intel acquired a few years ago. But Mobileye was doing some of the camera processor chips for autonomous vehicles. And so they were licensing their technology to what they call a tier one automotive suppliers. And so we're basically using a very similar approach in LiDAR, where we've developed all this technology, very next generation oriented LiDAR design. So we've got this excellent system design and reference architecture, and then we've got a tremendous amount of software around that. So then we're going to license that technology, design, and software to tier one automotive suppliers, and then they'll take it to market. So they'll actually build that product and sell it to the automotive OEMs. So one of our partners in that is Continental, which you may know from their tire business. A lot of people know Continental tires. But Continental is also one of the foremost leaders in radars and cameras and advanced driver control units as well, and LiDARs. So they've sold, I think, over a 3-year period, over 100 million radar and camera units in just 3 years. So they're one of the biggest players in that space. So they're one of our key partners that we've announced. And so we're going to be licensing our technology to Continental, and then they'll actually build and design the actual box that will be sold to the OEM. So the actual LiDAR sensor will be sold by Continental, and we will take a licensing fee off of that. So that's what we're doing in the ADAS space. And then in the industrial and mobility markets, we're actually going to produce a physical product, but we're going to do that through contract manufacturers. So we recently announced we're working with 3 contract manufacturers, which is Sanmina, which is one of the biggest in the world, Benchmark and Fabrinet. And so Sanmina is going to do all the final assembly and test of these sensors for us for the industrial and mobility market. So we have the licensing side in automotive, and then in industrial and mobility, it's a product that's made for us by contract manufacturers, and then we'll sell that product into those other markets. So that's very capital-like business model, because we're not going to build factories, for example. We don't have to carry all that working capital. We don't have to put concrete in the ground and build all that stuff ourselves. So we're going to work with people that are already well established in those areas and use those existing value chains rather than trying to recreate the wheel effectively. So back to that industrial mobility area, you asked about, AI is going after a number of different areas. Mining is a big one because there's all sorts of autonomous applications around mining. They need very robust sensors like ours that can sustain a lot of shock and vibration. Shuttles, so people shuttles, you hear a lot about fully autonomous shuttles, delivery vehicles or delivery bots. Rail is a key application. So you can imagine rail cars going down a track and wanting to see far down the track to make sure there are no obstacles in the way or people. And also platform safety for rail. Aviation, so you can put these on helicopters or planes. You're actually seeing LiDAR deployed on spaceships already. Today, those are very high-end systems, but there are going to be more and more applications around the space area. Drones is another example you mentioned. Traffic systems is a really exciting area for us. So we're working with Mitsubishi Electric around some of the areas around intelligent traffic systems. And so you can imagine in the intersection, right, anywhere you've got a traffic light, you could potentially put a LiDAR. And well, why would you do that? Because you want to, as a municipality, you want to be able to manage your traffic flow more accurately. And you want to be able to see how many vehicles there are in a particular intersection. You want to be able to count the vehicles. And LiDAR is really good at counting things, right? Because cameras have difficulty telling depth, right? Which is one of the reasons you use a LiDAR to begin with. But LiDAR is really good at determining depth, so it can measure and distinctions between different vehicles where a camera might see only one vehicle where there might be two or three. LiDAR is much better at distinguishing those things. So you can see anywhere you might have a stoplight. Eventually, you might see a LiDAR. So that's sort of the long-term vision. But we're already seeing different municipalities starting to deploy LiDAR for that use case. So you can see how that might expand over time if you can start getting into intersections and how many intersections are there in the world that could benefit from having LiDAR attached to them. So those are just a few examples. Another one is physical security, where it can, again, be very complementary to cameras because cameras get a lot of false positives or don't see things. And one of the things we haven't talked about yet on LiDAR is, it sees really well at night, whereas cameras have often difficulty in low light environments. Whereas LiDAR is its own source of light, right, because they're shooting out laser pulses. So anywhere you have low light conditions, LiDAR is very helpful as well. And so you can imagine physical security applications where that would be useful. And also defense is a potentially big market for us as well.
And I can imagine almost all robotics would be useful for as well, I suppose, autonomous robots, etc. They need to know their environment and move around.
Yes.
Sort of, I don't know, I'm not sure if they do use this technology, but Boston Dynamics, I imagine those robots use something similar.
Yeah, so a lot of robotic applications are using LiDAR today, and we think that's going to grow a lot. I mean, our view is LiDAR is going to be everywhere. So you're already seeing it in the latest iPhones that have come out. So they're using it, that's kind of a low-end LiDAR just mostly for picture tagging and improvements there. And I already mentioned spaceships, right? So you're seeing them on everything from iPhones to spaceships, and our view is you're going to see LiDAR go on everything in between. So ultimately, anything that moves or anything that wants to track something that's moving is a potential application for LiDAR. So our view is LiDAR is really going to be everywhere. So the opportunities are just enormous for LiDAR generally.
Mm-hmm. And just bringing it back to autonomous driving again, let's just cover the US to begin with. When do you think it's going to become sort of a reality that we start seeing this in cars on the road in the US?
Just in the next couple of years, you'll start to see it. I mean, there are some examples, some very simple LiDARs that might be used for automatic emergency braking today. There are a few examples of that already, but we're going after higher end use cases like highway autonomy. So our goal is to make sure your vehicle can actually drive down the road by itself, and for that, you really need a long range, high resolution LiDAR like AEyes to do that. And we've announced with Continental that there will be a start of production for AEye's LiDAR in 2024. So that's what they're working towards, and they're they're actually already building a factory line in Ingolstadt, Germany, for those units. So they're already generating sample units off that line. So they're telling their investors and customers that they expect to have started production in 2024. So it's not very far away before you'll start seeing LiDAR on vehicles that you can actually go purchase from a dealer.
Yeah. How quick do you think it would be for mass adoption to occur in that sort of industry? Do you see that as a slow to begin with and then it become all at once? Or do you think it would be quite quick adoption? You know, people just it will become the norm very quickly.
Yeah, I mean, for our purposes, we've assumed it's going to grow, rather modestly for the next couple of years. So we're not expecting huge penetration over the next couple of years. Initially, it'll start on some of the higher end vehicles, and then it'll grow from there. Once it's in the higher end, then it tends to filter down into the mid range and ultimately into the lower end vehicles.
Yeah.
So we think the opportunity is great for AI in that context. Particularly, for the higher end vehicles where it's going to start, they really want to have this highway autonomy capability, right? Because that's a feature that the automotive companies can sell, right? That's really valuable to people that, they want to be able to take their hands off the wheel and relax and let the car drive itself when they're going to a meeting, or they want to be able to watch a movie or whatever it is. And initially that'll be, probably level 3 systems where the driver still has to be ready to take the wheel. So you got to still have your eyes on the road, and ultimately migrates up into level 4 where the car can basically drive itself in almost all use cases. And then you get to what they call level 5, where there's effectively no steering wheel and no accelerator and no brake, right? The car just completely drives itself at level 5. So all that's going to start to happen. It's already starting to happen now. But when do you really hit mass adoption? It's probably several years down the road before you really get to mass adoption. We're already seeing tremendous interest in it. So we think there'll be a fair amount of uptake because, there's just a lot of consumer interest in that capability. And I think at the right price point, that'll be a really interesting thing, both for the customers as well as for, the auto companies that want to sell those features. So they'll be selling both something that's, very convenient feature, makes your life easier and better, and also makes you safer.
And will trucking be first, do you think, or autonomous cars for the normal person?
Yeah, they're sort of neck and neck. I mean, we're seeing a lot of applications around the trucking side. So they're already, starting to deploy it on the trucking side. So you may see the trucking happen a little bit faster, but the automotive side is right on the heels of that. So they're very close proximity, and a lot of work going on in both the passenger vehicle side as well as the commercial vehicle side. So we think a lot of opportunities for AI in both of those segments.
Yeah, you can see how the trucking area, riding on the trends of supply chains are getting stretched. There's more demand at the moment for e-commerce, etc. You need more vehicles, and there's less actual individuals around to drive these trucks. That it's going to push forward this advance quicker, I would imagine.
I think you're spot on there. Exactly right. So I think there's a real commercial need to solve that problem. So you had a strong economic use case on the trucking side. So that's why there's a lot of money and effort going into that space. And to your point, there's this driver shortage we talked about. And there's also the driver fatigue and safety issue. So everybody is highly motivated to solve that problem. So I think there's going to be great opportunities there. And trucking particularly is one that's really well suited for AI because we've demonstrated we've got the longest range in the industry. So we've actually had a third-party lab test our sensor at AEye and validate that we can do 1,000 meters. So we can see a truck or a road sign at distances up to 1,000 meters. And I think we're the only company that's done a third-party validated test to demonstrate that. So you can imagine how useful that would be for trucking, right? Because these are obviously very large vehicles with long stopping distances, right? So it's not like your passenger vehicle where you can, stop in, 100 feet or something if you need to, or 200 meters. These vehicles require a lot of time to stop, particularly when they're loaded. So, that's something that we're really well suited to address. And, not just the long range, but you also have to be able to see things in very high resolution. So, A lot of our customers are trying to figure out, okay, can you see a brick in the road at 160 meters as an example? So you can imagine, all the different, you've probably driven down the freeway yourself and seen all sorts of obstacles in the road you weren't expecting. My wife last year drove over a tire jack that fell off another vehicle.
Wow.
And totaled her car, right? So imagine if you had a brick in the road or a tire jack or anything like that. You want to be able to see that far enough in advance with your LiDAR that you can actually, take evasive action or stop the vehicle. So our ability to see those kinds of objects in very high resolution at long distance enables you to, change what the vehicle does and makes you safer, right?
Mm-hmm.
So that's, and so you can imagine that's very important for trucking to be able to do that at distance, but it's also, of course, very applicable for passenger vehicles as well.
And why should people choose? Why do you think AI is going to be successful over other LiDAR companies? What are the sort of unique selling points? I mean, we've definitely touched on a few, but summing it up, such as your range of the LiDAR, etc. What other things give you these USPs?
Yeah, I mean, we're really software configurable, so we can do a lot of different things, so we can solve a lot of customer needs. So it's a very flexible technology architecture that we have, so it can do almost anything that a customer would want it to do, right, within the confines of the performance specs we just talked about. But it's very adaptable to different situations. So it's unique in that aspect that it can adapt to different environments. And it has a lot of flexibility. So that's one of the reasons that Continental selected AI, is it's a very flexible architecture. And because you're going to have a lot of different customers that may want to do things slightly different. You might have, automotive company number one that wants to implement it this way, and they might want to put it in the front grille. Automotive customer two might want to put it behind the windshield. Automotive customer three might want one, backward facing as well as forward facing. There's all sorts of different use cases. So having both high performance and flexibility is really critical, particularly for something that's a new and emerging technology in this space is really critical. So we think there's a lot of interest amongst both the tier one automotive suppliers as well as the automotive OEMs and the trucking companies to have a solution like this that they can adapt to their needs. It's not us telling them here's what you need to do. We're saying we've got an adaptable sensor that we can software configure for you. What do you need, right? So we're, I think, uniquely well positioned at AI to solve the customer problem in whatever way they need it solved. And then we have this business model where we're working, as I said, with automotive tier one suppliers. So that's really important for a lot of these automotive customers is that they can rely on a major automotive supplier that they've been using for 50 to 100 years in many cases for some of these auto companies. They want a product, they have to have a product that is automotive grade, and they want to be able to rely on a large automotive supplier to stand behind that rather than a small technology company like AI. So as a result, we're using that same sort of model we talked about that Mobileye has, where we license to the automotive tier ones, and then they actually sell the physical product. They make sure it's auto grade. They make sure that it can sustain all the temperature and shock and vibe requirements that the automotive OEMs require of an automotive grade product. So we're not trying to do that ourselves. We've always said we should do what we're good at. AI is a technology company, right? We're not an automotive supplier. So we should develop technology. We should let the automotive suppliers be automotive suppliers. That's what they're good at. So let's, basically, perpetuate our technology and try to make it pervasive and give that through a licensing basis to the suppliers and let them sell the physical product to the OEMs. So we just think that's a better way to go to market. So it's a combination of this, what makes us different is this great business model that we've got. We think we've got the most advanced and most adaptable technology. And then we've got a great management team, which we've touched on a little bit here, but we've got a very experienced public company management team, which a lot of LiDAR companies don't have. We've just got more experience running public companies than a lot of our peers may have. So we think that's going to be a big differentiator for us as well in the public markets for AI.
Yep. And it's still founder-led, I believe, which is great. And one thing I wanted to touch on just before we wrap up was Tesla obviously have a different approach to mapping their environment. I think it's a camera-based system. Why do you think they've chosen that, and what are the benefits of LiDAR over Tesla's approach?
Yeah, I think from our understanding, I think they had been using radar and camera, and then they recently pulled out the radar. And our understanding is that they were probably getting some sort of, conflict between what the radar was telling them and what the camera was telling them. And so as a result, they just decided to pull the radar out, is our understanding. So in any case, our view is, and I think everybody else in the industry, other than Tesla, is saying you really need LiDAR to solve this problem. And I think part of the issue probably for Tesla historically has been LiDAR has been too expensive. So if you're selling something called full self-driving, you can't very well say, well, it really needs a LiDAR, but I'm not going to put it on there, right? You're going to say, well, it works fine with just a camera. But there are plenty of examples where it hasn't necessarily worked fine. And our view is cameras are good, and we're not saying we should replace cameras. We think they're complementary to LiDAR, and we think radar is complementary. And there's also ultrasonic for short distances. So all these sensors we think are complementary, and what you really want in an autonomous vehicle system is redundancy, right? If one sensor isn't working, whether it's because the sunlight is too bright or it's too foggy, whatever the issue is, or it just plain fails technically, you want another sensor or multiple sensors that can pick it up and basically complement or replace the sensor that you may have lost, or the sensor that's not delivering the information you're expecting to get. So it's really about redundancy and safety in our view, and that's why we think the vast majority of the market is going to want LiDAR and is going to deploy LiDAR. And Tesla's one exception to that. But I think when LiDAR gets cheap enough and good enough that, that who knows, they may very well revisit that. Certainly that's going to be our goal, is to make sure we can make this very high performance technology that AI is delivering and get it into vehicles at the right price point and put it everywhere.
Well, yeah, it does sound very exciting, Bob. So it's great to have your insight on LiDAR and AI. I'm sure people will be very excited to see what happens over the years to come. And you recently listed under the ticker LiDAR, which is LIDR, I believe, and that shouldn't be confused with the stock AudioEye at all. It's AEye is the actual name of the company. Where can people go to learn more about AI and follow the company news and announcements, Bob?
Yeah, please go to the investors section of our website, which is AEye dot letter A, letter I. So AEye.ai. And go to the investor section there. You can sign up for alerts. And we say AI is LiDAR, LIDR. So that's our new catchphrase. So when you think about LiDAR, think about AI. And we're very excited to have listed on NASDAQ, and just got to ring the bell on NASDAQ Wednesday last week. So very excited to be in the public domain now and have the capital to go execute on AI's vision here.
Yeah, congratulations, Bob. I wish you all the best in the future, and the team as well.
Likewise. Thanks so much for having me.
Cheers, Bob.
Cheers. Bye-bye.
Thanks for listening, everyone. Just a quick note before we sign off. If you're looking for an easily digestible daily update on the markets, this might be of interest. Opto Updates is our short newsletter sent every day during the trading week, giving you a bulleted list of the top 7 stories from the global stock markets. We've done the hard work for you, highlighting relevant opportunities and trends. And in addition, we'll also keep you notified of any new products, stock reports, or webinars from the Opto world. If you're interested, sign up using the link in the show notes. And thanks also to Co-Fruition for consulting on and producing the show. Until next time.
Co-Fruition.